Hello everyone and welcome to the lesson on integration, kcse 2006, paper 2, question number 24. So let's go straight to the question. The question reads, the diagram below shows the sketch of the line y is equals to 3x and the curve y is equals to 4 minus x squared, intersecting at points P and Q, as you can see in the diagram. The first part of the question, find the coordinates of P and Q, that is 4 marks. Then part B, given that Qn is perpendicular to the x-axis at n, calculate part 1, the area bounded by the curve y is equals to 4 minus x squared, the x-axis and the line Qn. You can see the points there, Q and N is shown there in the diagram. Part 2, the area bounded by the curve y is equals to 4 minus x squared, the x-axis and the line Qn. Then 2, the area of the shaded region that lies below the x-axis. The third part of the question, the area of the region enclosed by the curve y is equals to 4 minus x squared. The line y is equals to 3x and the y-axis. That is the last question. So let's go to the first part of the question where you're supposed to find the coordinates of P and Q. So the coordinates of P and Q, you can see the points P and Q. Those are the intersecting points of the curve and the line given. So we're supposed to get these, and to get that we need to equate the functions y is equals to 3x and y is equals to 4 minus x squared. So we shall take 3x and 4 minus x squared. We equate the two values, the functions, and then we solve for x. So both of them are functions of y, so we take the right hand side of the equation and equate. That will give the point of intersection of the two curves. So solving these, this is what you get. Organizing this to form a quadratic equation and then dividing everything by negative, you get x squared plus 3x. This will be negative 4 is equals to 0. So factorizing this equation, this is what you get. So when you factorize this equation, you get x plus 4, x multiplied by x minus 1 is equals to 0. So that is what you get when you factorize that equation. We're simply getting the point, the value of x where the curve and the line are intersecting. So the first value of x will be negative 4 or 1. So they're intersecting at 2 points, negative 4, x is equals to negative 4, and x is equals to 1. Now, to get the y values, remember, for us to give the coordinate is supposed to be given in terms of x and y. So we only have the x. We need to get the corresponding y values for each of those points. We shall use either of the equations. We can decide to use y is equals to 3x, or we can decide to use the other equation, that is y is equals to 4 minus x squared. So when you use this equation, when y is equals to 3x and x is equals to negative 4, y will be given by negative 12. Then when x is equals to 1, that is the other value, y will be given, just substituting, y will be given by 3. Now we have the corresponding, we have the x and y. So when x, so to get p, we need to get now p. For p, the value of x at p is 1. And so when x is equals to 1, y is equals to 3. And then when x, that is for point q, we got the x value as negative 4. So when x is equals to negative 4, y will be negative 12. So those are the coordinates of point P and Q. So now we have obtained the coordinates of P and Q. Let's go to the second part of the question. And the second part of the question, we are required to, given that Qn is perpendicular to the x-axis at n, calculate part 1, the area bounded by the curve y is equals to 4 minus x squared, the x-axis and the line Qn. So let's go to the diagram and see. You can see Qn, And then we have the area that we are required to give that is bounded by the curve, the x-axis, and qn is that region that is there. So the area bounded by y is equals to, that is the curve, then the x-axis, and the line qn is that region that I've indicated there by use of the arrow. That is the area that is unshaded. Now that point, we got that point, the value of x at that point is -4, that is at n. And then we need to get, there is another value we need to get. There is this point, I will call this point M. This is the intersection of the curve and the x-axis. So to get that, we need to know something. So we want to get that point where the curve cuts the x-axis. You've seen it cuts the x-axis at 2 points. So get points where y is equals to 4 minus x squared, that is the curve, cuts the where it cuts the x-axis. And to do that, we are going to take, at that point where it cuts the x-axis, the value of y is 0. So we equate that function to 0. So 4 minus x squared is equals to 0. And these, when you factorize, these are difference of two squares, 2 plus x, 2 minus x. Factorizing that, you get two values of x. That is 2 points where that curve cuts the x-axis. And these are the points. The first one is x is equals to -2. And the second one is x is equals to 2. So the curve cuts the x-axis at 2 points. One is -2 and the other one is 2. Now I was looking for this point, this m. So it is on the negative side, so automatically that will be -2. We have got two values where it cuts the x-axis. So one is -2, the other one on the right hand side, the positive side of the axis, will be 2. So the other point, this is the other point to the right, that will give 2. So those are the 2 points. The reason why we're getting these points is to enable us to get that area that we were finding there. We identify that region that you're supposed to find. That's the region I've indicated by the use of R. So we're going to integrate the equation, the function of that curve, and the limits that you're going to use is from -4 to -2. So to get that area, we are going to integrate the function of that curve. So because that region lies below that curve, so from -4 to -2. So that is what you're going to do to get the area of that region, so with respect to x. So we integrate these using the limits that we have there. Now working out these, integrating these, you get 4x minus x cubed divided by 3 plus a constant c, the square bracket, and then the limits from -4 to -2. Now substituting these to get this area, we start by substituting -2. Substitute -2 in that equation, you get -2. This is a cubed divided by 3 plus a constant c, the square brackets. Don't forget, these square brackets are very, very important. The square brackets are very important. Then we substitute -4, subtract, this will be -4 cubed divided by 3 plus a constant c, then close these using the square brackets. Now working out the first part, you get this will be 4 multiplied by -2, this will give -8, and then this will give this will be positive 8/3. I'm ignoring that constant c, since upon subtracting the other bracket, the c constant will disappear. It will subtract and you get a 0. So the right hand side, you get -16 plus 64/3 very fast. And these When you work out these, negative 8 plus 8 over 3, this gives 16 over 3 negative, that is. Then subtract. When you subtract these on the right hand side, you get 16 over 3. This will give negative 32 over 3. Writing these as a mixed fraction, you get negative 10 and 2/3 square units. Now, we shall not write this area as negative. We shall ignore the negative sign. The reason is because the negative just indicates that the area falls below the x-axis. So when you're writing the area, we consider the positive part. We ignore the negative. So that is the area of that region, 10 and 2/3 square units. Now, after getting that area, now let's proceed to the next part of the question, which is the area of the shaded region that lies below the x-axis. The area of the shaded region that lies below the x-axis. Go to the diagram. Note that area that is below the x-axis that is shaded. You can see it there. So it runs from x is equals to negative 2 to 0. Below. It is below that. So to get that area, this is what you're going to do. The shaded area will be given by the area of there is a triangle there that I want us to identify. Look at triangle NQO. That is a right angle triangle, NQO. So the area of triangle NQO, subtract the area that we've just calculated in the previous part of the question, which is 10 and 2/3 square units. So we've just calculated that area, so we don't need to repeat. Now what we need to get here, the main area of focus is area of that triangle NQO. The area of that triangle, that is what we need to get. Now to get that, look at this triangle. It runs from 0 to negative 4. Those are 4 units. That is a base. 0 to negative 4. Those are 4 units. So the size of that. Then the y, the corresponding y value there. Remember, we got the coordinate of q as negative 4, negative 12. So that height will therefore be 12 units. The height will be 12 units. That one will be given by that coordinates of q gives everything there. Now, getting the area of that triangle, therefore this gives a half times the base, which is 12 times 4, very straightforward. And then we subtract the area that we just calculated to remain in the shaded area below the x-axis. This gives 24. Subtract 10 and 2/3. Subtract 10 and 2/3. And upon subtracting these, you get 13 and 1/3 square units. 13 and 1/3 square units. That is what you're supposed to get. Now, upon getting that, there's something else that we need to do now. That is for the last part of the question. The area of the region enclosed by the curve y is equals to 4 minus x squared. The line y is equals to 3x. Correction there. That is, should not be y negative 3x. Y is equals to 3x and the y-axis. Basically, that represents now the whole shaded region that you can see there. So we need to calculate the whole shaded region that you can see there. So the whole shaded region, it has two parts. The shaded area below the x-axis, we've just calculated that. Now we need to get the area, the shaded area above the x-axis. The shaded area above the x-axis is what we need to get. So to get this, we shall get the area below the x-axis, that is the shaded area below the x-axis, plus the shaded area above the x-axis. I mean, that runs is given by the limit negative 2 to 0. You can see where it starts. Then that area above that is shaded there. This one we shall get it by integrating from negative 2 to 0. Do that integration, integrate the equation of the curve, that is 4 minus x squared with respect to x. That is the overall shaded area. That is shaded area above the x-axis. So the whole of this is going to give us the shaded area, the entire shaded area in the diagram that we have there above. The whole of that is 13 and a third, and then we add the integration from negative 2 to 0 of that function. That will give the area above the x-axis. Now let's get the area of this curve that is shaded above the x-axis. So the limits negative 2 to 0, 4 minus x squared, this with respect to x. When you integrate these, we get 4x minus x. We had done this before. The limits are from this is negative 2 to 0, and then this gives when you substitute 0, we get 0 plus c. Then you substitute negative 2, the other limit, that is a 4 multiplied by negative 2, subtract negative 2 cubed divided by 3 plus c. So this gives c, subtract this will give negative 8, then minus this will give positive. When you work it out, to give positive 8 over 3 plus c. Then from there, c, subtract this will be given by what? There's something here. So when you subtract these, you get positive 8, and then negative 8 over 3, then subtract c. So c will subtract each other, and we definitely get a 0. Then 8 subtract 8 over 3, this gives look out these. This gives so when you subtract these 8 subtract 8 over 3, you get 16. Just confirming something here. This is 16 divided by 3. That is what you get. Now that is now the area, the shaded area above the x-axis. So we have to get to add the shaded area below the x-axis to get the entire shaded area. Therefore the entire shaded area that is above and below the x-axis will be given by 13 and a third square units. Then we have to add 16 over 3 square units, and this definitely will give this gives and you add these, you get 18 and 2/3 square units. 18 and 2/3 square unit. And that is how you're supposed to solve that question on integration and area under the curve.